think we're good to start. So yeah, thank you, Sam, for starting this chapter of Papers We Love. Actually, I wonder if I can get rid of that little overlay. There we go. And I'm Mark Masse. I'm going to be talking about this paper that I do actually love and have read many times as part of a lot of research I've done on the subject of REST. The paper is Architectural Styles in the Design of Network-Based Software Architectures. It is by Roy Fielding. It is actually his PhD dissertation. I think many of us know this paper, but we will be going through it and kind of starting with a little bit of context of like some of the history stuff. So as you can see that from I kind of did a visual representation of the presentation's outline. So just kind of so what you have to look forward to over the 30 or so minutes that I'll be kind of talking through these slides. And so I'm going to start with a little bit of the history of the World Wide Web itself. I think the history is fascinating, and I think it just is a really cool story in general. And then we'll pick up with the actual paper, and that's Roy Fielding there. And then we'll go through what I think of as I guess maybe from my perspective anyway, it's like the meat of the paper, which is chapter 5, and it is really where he introduces the notion of REST and introduces the term REST and talks about what it is. So that's going to be a lot of what we focus on. And actually, with the focus within the focus is going to be on the uniform interface part. So that's this piece here, which is, you can see the top there. So we're going to kind of drill through all of the different constraints that he outlines and then really zoom in on that one. And then the last kind of zoom in we'll do is actually on that top blue piece, which is the fourth constraint within the constraint, which he refers to as hypertext as the engine of application state, or the horrible acronym HATEUS. So we'll talk a little bit about that. I organized it this way because a lot of what I'm interested in is REST API design, and the design of an API really is in the domain of this uniform interface. So that's, in a lot of ways, the most controversial and therefore the most interesting part of this subject matter from my perspective. So that's the flow. So just a little bit about me, so you know kind of who you're listening to. I went to University of Colorado in Boulder, graduated with a degree in computer science. I was there in the late 90s, graduated in 97. One of the things that was interesting that happened while I was there is Java came out in alpha, and that had a big impact on me. I started programming in Java from the very beginning. Some dudes in my CS library had picked it up, and I just thought it was super interesting. And specifically, the main thing you could do in Java back then was create Java applets. And I wrote a few applets, and I think basically if you did that back then, you were at least sort of internet famous. So like some of these silly applets I wrote were like in books and stuff, which is just kind of a sign of the times. But it was a big enough deal for me that I got a job at that company up there called Starwave, which was a Paul Allen startup based in Seattle. And they had pivoted from doing like multimedia CD-ROM software back in like the heyday of multimedia, like, you know, Mist and like Sound Blaster and all that stuff, when PCs had CD-ROM drives and sound cards and everything was amazing. So they pivoted from doing that kind of software to doing websites. And so when I joined, they were doing the website for the NFL, NASCAR, NBA, ESPN, Disney, ABC, and a few other sites. So it was like 200 people doing all these big websites, but back when the web was super young and websites were definitely not what they are today. So anyway, fast forwarding a little bit, Disney actually ended up buying Starwave. I ended up working at Disney for about 14 years, all told. The last several years were at ESPN. My whole career, especially at Disney, was either I was doing front-end stuff or I was doing web publishing. So I worked on some systems that were doing content management, but it was all just like super web-focused, and that really kind of dovetailed into me being interested in REST and driving some API standards. Like how we would design APIs in a consistent way at Disney was a big thing for me. That led to me, I ended up taking a job at Mashery, which is a smaller company in San Francisco that got bought by Intel. And their main product is an API management system. So I was there for actually less than a year when Riot contacted me, and just like as a lifelong gamer and actually a player of League of Legends, I was just like, thought the opportunity was amazing. So that brought me actually out of Seattle, and I moved down here. So that's a little bit about me, and if you want to know more or whatever, we can certainly talk later. But sort of getting to the heart of the beginning of this. So this paper fundamentally describes the World Wide Web. Specifically, he talks a lot about the architecture of the World Wide Web. To me, the web is this amazingly awesome thing. I think like if there was an asteroid headed towards Earth, we would figure out how to eject the web into space, like as a sustainable thing. Like I think of it as like a wonder of the world. Like literally, I don't think that there's any modern piece of software that comes even close to sort of the amazingness of it. That's just my opinion, I guess. So you know, I'm interested in it and wondered, you know, kind of where it came from. And so I wanted to kind of learn more about the history. And I think a lot of us kind of know some of these details. You know, and we'll go through it pretty quick. I won't dwell too much on it. But the web was created at CERN, which is largely known as a research facility. It's located between Switzerland and France. And it was created by this guy, Tim Berners-Lee, who was a software engineer working at CERN. And one of the things that's fascinating to me is he had basically just got this new Next computer. So he was like super psyched about it. Like you can see like in a lot of his early writings about the web, like he attributes a lot of his inspiration of the web to the way that Next worked, the Next Up operating system, and just wanting to program something, like wanting to build something cool with his new toy basically. And so he had actually a problem that came across his desk basically that he needed to solve, which is the idea that the researchers that were spending their life's work working at CERN were doing so like in very siloed ways. Their documents weren't formatted to be easily shared. They would like, move on from CERN one way or another, and a lot of times their research would just be lost. And so like you spend your life working on something and then it's just basically like goes nowhere, which essentially like slows overall progress. So he saw this and essentially thought, well, I need to build a document management system or a way that enables these guys to not only like see and reach each other's documents, but ideally like link to them. And he was aware of hyperlinks and hypermedia systems. He had seen like help systems, like we think of as like old Windows help. You know, those systems existed for like hypermedia driven. Certainly not on like the web scale, but the idea that you'd have documents linked was already a thing. So he was inspired by a lot of these things. And you know, again, if you read more into like the history of the web, it wasn't an accident that like he ended up creating the web. He definitely overbuilt, like massive scope creep. Like the problem he needed to solve did not warrant the solution that he came up with. But you know, it's cool. Like he just basically saw like, hey, I can make this generic. Basically, like we all, I think, have a tendency to do. But he actually also had a vision for what it could become. Like it wasn't like a huge surprise to him that it grew the way it did or that it became what it is. I think he, in some ways, saw that as the possibility. So it's fascinating to me. So he basically like soloed this project. He literally, in his editor, created a project called World Wide Web. And in the process, in the course of this project, he invented URIs. So came up with like this universal like identification system, which is pretty badass. Definitely better than like Dewey Decimal. Invented HTTP, so the generic like protocol for communication. Invented HTML, and he wrote the first web page, which you can see there in the language that he created. He invented the web browser and wrote the first web browser in Objective-C. You can see that's a screenshot of it running on his Next computer. And I don't know if you could read the top left, but it says World Wide Web, all one word, very programmer-like. And it was later renamed to Nexus, which I thought was funny. That building we were just in is called, where we were eating, was called the Nexus. So it's just weird irony. So he did all that in 1 year. I asked like at dinner tonight when I was sitting there, I asked if like anyone had any side projects and how long they had worked on them. And a few people said, you know, a year, 3 years. Somebody said 30 years. But you know, Tim Berners-Lee basically cranked this out on his own in a year, which is pretty awesome in and of itself. And just to kind of make it a little bit more real, again, I don't know if you can see this all the way in the back, but this is cool to me. This is a actual like .m file from the implementation of the browser, and you can see like the author line is Tim Berners-Lee. This class that we're looking at the top of is called hypertext, and he says in the comment he says hypertext is like text, but includes links to and from other hypertexts. You see also the anchor class, the history, which is fun, which is 1990, which is when he invented the web. It says written by Tim Berners-Lee with the help of the interface builder. So even in the comments, you could see like him giving a nod to the tool of his Next computer and the tool set it supplied. He's almost like co-crediting like the UI builder, which is cool. It's like importing HTML.h. So cool stuff. So last bit about Tim Berners-Lee. I mean, and I think where we're segue into talking about Roy Fielding is, I think he was a software architect genius. I mean, he based the system he architected is super impressive, and that's a lot of what we're going to be talking about in this paper. So this is Roy Fielding. His background is that he actually co-authored with Tim Bernerslee the RFC for URIs and also for HTTP 1.1. And he was actually fairly instrumental in taking HTTP from 1.0 to 1.1. So he was early on working with Tim Bernerslee on the web, like on the implementation of it specifically, and was one of the folks that rallied behind the implementation of HTTP 1.1 as a reaction to what appeared to be the scalability problems with the 1.0, specifically things like lack of support for caching in a uniform way. This is the only picture I could find with Tim Bernerslee and Roy Fielding together, which is pretty funny because Tim Bernerslee like on a floating head on the computer screen, and that guy's giving him bunny ears. It's pretty funny. Anyway, so moving on. So this is what Roy looked like back when he wrote the paper. He went to University of California, Irvine, which I did not know this, but their mascot is the anteater, which is pretty amazing. And now it looks more modernly like that, which I think is pretty scary. I don't know if you can make an anteater look cool. They tried, for sure.
Better than the banana slug.
It's better than banana slug. So yeah, so a little bit about Roy, his background. So he co-founded the Apache HTTP server project. I mentioned his work on HTTP 1.1. He helped to standardize the web. We mentioned the RFCs. I'd say also this paper that he wrote is a big contribution to the standardization of the web. And so that brings us kind of back to where we started, which is we're going to be talking about his PhD dissertation. And so the rough outline is presented on the left, or the actual outline of the paper is presented on the left. I've highlighted chapter 5, which is entitled Representational State Transfer, and then REST in parentheses. And it's not necessarily totally obvious. Hopefully some of you have found this paper interesting and have read it, but basically my synopsis, given that we're going to kind of have a focused discussion on chapter 5, my synopsis of the chapters leading up to it is that they largely build up toward the derivation of REST in chapter 5. So he's giving a survey of different network architectural styles. It's very interesting stuff, but he's mostly doing it as a way of comparing and contrasting it to the web, the web's architecture. And the spoiler alert is that REST is the architectural style of the web. So that's kind of the official definition of what REST means. So the meat of chapter 5 is this section 5.1 called deriving REST. And again, I kind of presented the outline here and mentioned earlier that we're going to be focusing on uniform interface, but he presents the chapter sections in this order. So starting with the null style, and then he presents client server. And so sort of on top of the null style, everything else he adds are what he refers to as constraints. So he's essentially, we'll talk about this when we get to the null style, he's basically starting with an empty set, and he's adding all of these constraints that kind of come with these other architectural styles, or really what there is like constraint categories. So we're going to talk about each of them pretty much in order. So then he talks about stateless, cache, and then he talks about uniform interface. We're skipping that to the end, so we go to layered system, and then code on demand, and then we will again talk about uniform interface. So that's going to be the outline for the next few sections. And because, like I said, I wanted to focus on uniform interface, we're just going to spend like basically a slide on each of the other ones. And I do want to, hopefully I'm not rushing too fast. I want to leave some time for discussion for as much as anyone that's interested in talking about this. So, but I'll probably also leave like questions for the end just to kind of, so I can kind of get through this. Unless you have something that's like burning and can't wait. Okay, so we're starting with the null style. So this is almost sort of like a mathematical thing for Fielding, the way he presents it, is that he's saying, basically I'm going to be deriving REST by adding a bunch of constraints. And think of it as like I'm unioning these sets of constraints together to ultimately form a big superset, which I'm going to call REST. So for just as a point of clarification, he's saying I'm starting with no constraints. So that's really all this is about, is we're starting with null, or the notion of emptiness, and that's the basis. So it's like a clean slate. So then the first constraint he actually introduced, or the first set of constraints, are the constraints that come from the notion that the web's architecture is, by definition, or in its nature, is client server. That is a fundamental aspect of the web. And as we go through, you'll see like all these things in his mind are like a fundamental aspect of the web. And I put some, like, what I thought were like some of the key sections or key passages from each of these chapters. You know, I could read them, but basically the key of this is that it's saying that with a client-server architecture, you naturally have a separation of concerns. You have two independent pieces of software that are, although they're communicating, they could vary independently over time. The server could be Python one day, Perl the next. You know, the client can be multiple languages. There can actually even be multiple different clients. And he also talks about the simplification of the server. So in a world where there was only the server, it would have to do everything. But he's saying in this world, the client actually has some horsepower and can provide some of the processing power to the overall equation and thus simplify the server, which is important, as we'll see. A lot of this is about scaling the server. So I think I hit most of those key points there. So the next thing he introduces is the notion of statelessness, and specifically, this is kind of people have like questions about this. I still have questions about this, like what is actually the implication of this? But the key point he's trying to get across is that the server in the web's architecture in REST is not responsible for remembering where things left off with client communication. So it's not expected to like remember this client and like remember where they left off or really remember anything about the client. It's kind of like the dude from Memento or something. It's like constantly forgetting, and he needs the client actually to remind him where things left off. So basically it puts the burden on the client to convey with each request really everything that's needed to pick up where things left off. That's really a lot of what it's talking about. And the subtlety of this picture is now, wow, there's 3 clients. So it's basically saying this allows there to be multiple clients and the server can just like handle that expansion of clients. That's the key idea there. And then caching is something, you know, we obviously have a lot of knowledge of this from our browsers to our caching tiers, but this is, you know, the introduction of it as a constraint. It's basically allowing for the idea that, and he represents caches with these little $signs at the client level, is that clients can choose to cache responses if the responses are explicitly labeled as cacheable, or they may be explicitly labeled as non-cacheable. But you know, if they are explicitly labeled as cacheable, then the client is allowed to go ahead and reuse that data for equivalent requests, you know, usually for some amount of time, or like until it changes in some way. So that's pretty understandable, hopefully. This one is a really complicated diagram, but basically just the idea that there can be network intermediaries introduced in the client-server communication. So there can be like things sitting in between the client server, and that shouldn't change the nature of their communication. Those things should be able to sit there and like provide a function without, maybe without even either party knowing that they exist. Things like caches, proxies, specifically talks about load balancers. You know, so the client thinks it's just talking to a server, but it's talking to a thing that's smart enough to like give it a server that's not under load. Like it shouldn't have to know. And that's kind of what this is all about. Just that by introducing layers, you can arbitrarily number of layers, you can like ease the burden. And again, another major contributor to scale. This one is, you know, very important to the web as we know it, especially. It's the idea that the clients are allowed to have basically a virtual machine of some sort that enables them to execute code that they download. So he talks a little bit, you know, it's a little bit esoteric. He's essentially talking about like, you know, these 3 things from an implementation standpoint, and many other things that have a similar kind of behavior, but the idea that you can download code and that essentially like the browser could, you know, in our world can do things that it wasn't coded explicitly to do, right? It has new functionality it's basically been extended on the fly. And it's basically saying that the best analogy I can give is kind of because you can turn off JavaScript in your browser, and because maybe the web existed for a long time without like this as a core part of the implementation, he's noted that it's the only optional constraint in REST. And what that fundamentally means is that if you were to take all of these constraints, when we get to all of them, but all the constraints that define REST, and you were to build a system that exhibited all those same constraints, not the web, but something similar that you could literally say, look, it has all these same constraints, you'd be okay to omit this one and still call it REST. You'd be okay to say, actually, my system doesn't support code on demand, and he would, like Roy Fielding in his definition would say, it's still REST because that one is optional. So that's kind of maybe the important distinction there. Okay, so now we're onto the uniform interface. This is one of my favorite pictures because he's basically showing the idea that you have this consistent server connector, which we think of maybe as like HTTP, but it could be exposing like, folders in one case, or like whatever these are, molecules, or I don't know what it says, or I don't know, some object model maybe, but the idea that you don't know what the server interface is, you don't know what the resources are actually implemented as, but the interface is consistent. So we're gonna talk a lot more about that one, but kind of get to the kind of payoff slide, which this diagram, as well as all these other diagrams, came directly from Fielding's paper. This one is the one where he basically says, ta-da, that REST has been derived. So the way you kind of read this is, starting with the null style, which is that black dot, you can add things like replicated to this thing, which is replicated repository. And then if you add this on demand, you get to caching. From here, if you add like separated, you get to client server. Stateless, you get to client stateless server. And then caching meets up, so you have client caching stateless server, and end up all the way over here with like layered code on demand client caching stateless server. So basically it all flows when you union all these things together. It's like almost like a big equation. You get to REST. And so that's, like I said, kind of the ta-da. That's the derivation part, by basically combining constraints. So the kind of nutty thing about the uniform interface constraint is that it actually itself consists of 4 constraints. So it's literally like constraints within constraints. And so so we're kind of restarting our agenda with this at this point with this as the baseline. So the uniform interface consists of identification of resources, manipulation of resources through representations, self-descriptive messages, and finally, Hypermedia as the engine of application state. So we're going to walk through each of those, and as I mentioned, I want to kind of end on a little more of the meat of the presentation will be on the fourth one there. So when he's introducing the notion of the uniform interface, he's basically saying the way the web's interface, the way the web's uniform interface works and the way REST fundamentally works is that you have this idea of resources, and that each resource has a unique identifier. And a URI is an example of such an identifier, and like as it's used in the space of the web. So I think for any of us that have been doing REST or web APIs or just like dealing with the web, I think this is a fairly familiar concept. Definitely took people a while to grapple with this, coming from things like SOAP. But this is a fundamental concept of REST, which is that every unique entity is a resource and has a unique ID. And then the idea that when you're actually wanting to deal with these resources or work with them or talk to them, you're manipulating the resources through representation. So when you say, I want to get, some car or some dog object, you're not actually like getting the resource. You're always getting a representation of it. And it's like a state-aware representation of what that thing looks like at the moment. And in the web, you're typically doing this through HTTP, and then you're, again, very commonly, most of us are using JSON for the representation side of things. So again, that has not always been the case. XML is still a thing. Obviously, it's still around, very popular, but JSON seems to be kind of taking on more life. So, and it kind of, as I'm talking about the uniform interface in general and these constraints, a lot of what I'm thinking about and what I think is interesting to talk about is how this applies to our API designs. Because I think a lot of us are in the space of the web and thinking about REST APIs, either working with them as clients or servers. And so sort of the reason I'm pressing the fast forward button through all these, and we can get back to it like discussions, is that I think that at this point, a lot of this stuff has been kind of paved or like, we've converged. Not completely, but there's definitely convergence around how we're doing these things. And I do not believe that to be the case on the Hypermedia. So the third one before we get to the Hypermedia one is self-descriptive messages, which I think sort of is mostly referring to the idea of like the metadata that comes, for example, in request and response headers in HTTP. So but the fundamental idea is that you can get a lot of information about the messages from the messages themselves. You're not having to have a lot of this extra state information or tracking it elsewhere. A lot of the messages themselves convey metadata, which is very valuable. Okay, so now HADIOS, the idea that representations contain links which the clients are meant to use to drive state transitions. So this is a fundamental question, which is, are we doing this? Like, do we have links in our APIs? And that's a lot of what I was hoping to get out of the discussion, is like actually talking to folks about like the state of the art there and where their designs are as far as that goes. And this dude, Leonard Richardson, wrote this book, Restful Web Services. And he also introduced, in a presentation he gave, this idea that Martin Fowler later dubbed the Richardson maturity model. But it was basically a 4-level thing, starting at level 0, which was like basically you're not doing much of anything RESTful. But level 1, he's basically saying a level 1 API exhibits that it's actually like using multiple URIs. So it's I guess properly identifying each resource with a unique URI. But it's like essentially like tunneling requests through GET or POST or something. So it's like not really making proper use of HTTP, but it at least is saying that, you know, for each individual thing that it's exposing, it's got its own unique URI. And then at level 2, a level up from that maturity-wise, it kind of fixes the HTTP thing and basically, like, you know, still of course retains the multiple URIs, but adds that there's like proper use of HTTP. And then level 3 is that the hypermedia constraint has been satisfied, and that the server is returning links, and the client's using those links as a way of driving the application. And so the question I guess I would pose is, you know, is this RESTful? The idea that you've met, you've done the first 2 things, you've made it to level 2. So is it RESTful enough to be called a REST API? And I think to me, it's an important question, because I would say this is what most of us have done. I mean, in my experience, most of the APIs I've looked at I would describe as like level 2 maturity on this scale. And most of those APIs, I think, proclaim themselves to be REST APIs. So this notion of RESTful, like the modifier there, is it even really a thing? And so I thought this quote from Fielding was interesting. So he basically says no, like there's no real concept of RESTful. It's like, he says, what needs to be done to make the REST architectural style clear on the notion that hypertext is a constraint? In other words, if the engine of application state, and hence the API, is not being driven by hypertext, then it cannot be RESTful and cannot be a REST API, period. Is there some broken manual somewhere that needs to be fixed? So that was on kind of on this forum thing. It was sort of came across as a bit of a rant, but yeah, I mean, he's kind of entitled, right? He created this thing. So kind of reiterated, hyperlinks are required. It is, in fact, one of the 4 constraints. So by basically not including it, you really have changed the uniform interface part. And I've apparently seen this enough to have said this: rules related to hypertext constraint are the most often violated within so-called REST APIs. Please try to adhere to them or choose some other buzzwords for your API. So I put in like REST-TM, right? Like he's basically saying like, I created this thing, I named it, it meant something specific, you're not doing that specific thing, so please don't use this name. Pretty clear. It's fair. So I kind of wanted to go through this little exercise of like what it's like as a client developer to work with modern client APIs. But first, let's look at like what it's like as a user of the web to work with the web and work with links. It's pretty straightforward. You basically just click on links. I mean, that's the end of that demo. It's pretty straightforward. So if we look at that same page, but seen through maybe the eyes of a client, there's no links. There's no, the API client, there's no links. So how do you navigate to, let's say we want to effectively click on that same thing, we want to navigate to this resource. So how do we do it? So as a client, we probably hard code something like the base URI is that, some API/v1. And we say, well, I know the thing I'm looking for is an article, and according to the documentation, those things live at articles. So I'm going to hard code that path as well. And then when I fetched the thing with the JSON, it said that this thing's ID was 80, and I know that the ID goes after that slash, so it's something like that. And so now I know I'm going to try to get that. And that aspect is also kind of a bummer, which is I just put the note that API client programmers also usually hard code the HTTP methods that are hopefully documented to work. Meaning, like, does delete work there? I don't know. Like, does post work there? I don't know. But get should work. So links, if you think about them in the web, there's no ambiguity. Like they convey exactly In the case of like forms, for example, they indicate the method that you should use to interact. In the case of like style sheet, they indicate things like the link relation. They have metadata of what the thing means. So on the human web, they're very important and very much used by the browser to do things like rendering style sheets and certainly rendering links to let you click on them. So I thought this was an interesting quote from Leonard Richardson. He said, here's the lesson of HTML. Connections between resources are a form of data, and they should be described in the documents with the rest of the data. It's like HTML has links right embedded in the documents. He says, let your clients focus on looking at that document and making decisions about what to do next, not on internalizing your particular rules about where on the web you put your data, which we just saw in that example. Like the client had to internalize or hard code a lot of those rules, which if you change those rules, they have to change all that code. Whereas if you change all your links, it actually doesn't matter, because if they're doing it right, they're not even looking at the actual links. And we're kind of actually rapidly approaching the end of the presentation, and this is kind of more just my pitch for that there are efforts being made to introduce Hypermedia into our APIs with I guess the 4 that I've shown here are 4 different examples that basically all do the same thing, which is they add the notion of what it could look to standardize what a link looks like in JSON in particular. So I thought we could look at a little sample of each of them. This one is by far the most complicated. I'm not an expert on any of these things, so I will just have that disclaimer. I know a little bit more about some of them than others. This is the one I know the least about, but it actually looks fairly interesting to me. He's kind of captured the idea of an operation here, and named what it is. He names kind of what methods needed to interact with it. And this part's actually really interesting to me, which is that he's gone as far as to say, here's a link to a schema that describes what I expect to get back when I call this. So it's essentially saying, here's like the return value of this function. And it's like typed. And I believe this part is a snippet of like JSON schema for validation of the thing that comes back. I could be wrong about that. If anyone has any expertise on this, I'd love to discuss it. The rest of them are much simpler, and they actually are all kind of like variations of a theme, which is that we're going to put a structure called links somewhere in the document, and it's going to contain things that contain href. So this particular case, it's underscore links, and the actual link relations, or the keywords that you'd expect the client to like hard code, are like self and friends in this case. They are keys to the object values. So that's one way of doing it. The next one is basically the same idea, but instead of keys to values, they are an array of consistent structure. So it's just an array of multiple links where each one has a link relation, an href, a prompt, which I believe is meant to be like a textual thing that you can display. This one I'm not sure. I don't know enough about collection JSON if the method is an optional thing, but it's actually one of the things I would love to see in the link is like actually what HTTP method do I use to traverse this link. It looks almost like get might be implied. Maybe that's the default and he just left it out. This one's so similar it's almost not even different. The interesting difference though is that it looks like here the relation is modeled as an array. So a given link can actually have multiple relations to the document, not just singular. In this case it does not. So that's the end of the presentation. I just wanted to kind of segue into one of the things that's most interesting to me in general with API design and as a subject is how similar all of our designs are, while at the same time still being different. And so I would describe a lot of the differences in APIs as like arbitrarily different. And I'm passionate about this idea that if we were to get closer to similar designs, we actually could, as a side effect, basically create what effectively is like a uniformly programmable web. Something that is so consistent that there really would only need to be one type of client to traverse all of the data. Something like a browser, but pointed at a programmable web. That's just a really interesting idea to me and seems totally achievable. The coolest aspect of that, if you were to endeavor to do that, to me, is that and I've seen it happen, and we all have, I think, in pockets, where once you standardize on designs, there becomes like a lot of development of tools around those designs. So like if you imagine like there was a consistent way of doing links, and JSON. There would probably be a lot of cool tooling. Things like Swagger might gain some cool new features that are like, hey, now we can totally work with your links. And so I think that the real great benefit of a standard API design and a universal one would be the increase in developer productivity as just the tools would start to appear. So that's the real passion for me in this space. And then I threw up some discussion topics and a little bit of like reading recommendations or stuff if you're interested. Talking through the books real quick. So that's Tim Berners-Lee's book, and it's, if you thought the beginning of this presentation was interesting, like the history of the web stuff, that goes into a ton more detail, and I think it's really cool to read. This book, The Web Protocols and Practice, is like my favorite book that I've ever read on the subject of HTTP. And then I think this book, for me anyway, was like the most inspirational book that I've probably read in general about REST. That's debatable, but it definitely has a lot of cool content around hypermedia. And then this book I threw up as a shameless self-promotion. I wrote this book about 3-4 years ago. It's a really small book, and it came out of some work that I was doing at Disney, where I was trying to standardize. You kind of get the bug; it's been in me for a while, but trying to standardize how Disney designed their APIs so that they would all be consistent, and made some good progress. I basically wrote a paper that Disney actually was cool enough to let me turn into this book. That's essentially the genesis of that. So I threw up some discussion topics. Sam, I don't know exactly how you usually structure this part of the thing, but basically I'm done, and thought that we could talk about these bullet points, or if anyone had questions or comments. Like, I'm happy to try to answer stuff. I'm happy to have like the group answer questions.
Yeah, I mean, we can just kind of open
up
the
discussion.
So you mentioned delete.
Yeah.
Is that really such a good idea? The concept of like when the web was developed, there was this idea of like sharing, but now we have like sort of spam, we have other things, and people are doing various things.
Yeah.
And how does a security perspective influence them?
I think that's a great. I mean, I don't have the perfect answer for that, but I do think that's where things like OAuth and like the rights and like the security around the user or the client of the API and their ability to access that method and that resource, I think is kind of how, sort of my hand-wavy answer to that. You'd basically want either an API management system or your own kind of implementation of controlling access. So, but I think the idea in general is cool, of the links describing what method you should use, and ultimately like that should obviously tie into like what the behavior is. That there's a big no-no on the web, which is like using the wrong method for the wrong thing or whatever. Like, you never want delete to do something other than like permanently nuke that thing.
Right. Because sometimes people try to like guess what your API is.
Right.
And then they try to like
delete stuff.
Garbage and then just
and I'm not like a web security expert by any stretch, but the basic idea for that, like I said, would be just make sure you have some security layer. So you want to let the clients do it that need to do it. Like admin tools need to delete data all the time. They should be able to do that through an API.
Well, I'd add too that like delete doesn't actually mean delete. Like, you don't necessarily, the thing that's actually in the background doesn't have to go away.
Right.
Like, the resource just has to no longer be at that URI.
Yeah.
So if you delete the customer, that customer may no longer be there, but they may show up now as a new resource,
right.
In another endpoint, so that you could apply another method to that and bring that customer back. Right.
Yeah.
So,
my rule of thumb for it is that after you delete it, a get should return a 404, but that's about the extent of what I'd say the delete had to actually have as a side effect. Yeah.
I think what's interesting is that probably a lot of people have had similar experiences where you sit down and starting from zero, I'm going to make the perfect API. And I'm going to do everything exactly the right way. I'm going to use all the right verbs. I'm going to link. I'm going to put all the right headers in. I'm going to turn the right status codes, etc., whatever. And you make this perfect thing, all these different objects at the most granular level, and then you get done and you're like, wow, I can't use this at all. I need to make 15 requests to do my basic thing.
Yeah, I'm super passionate about that subject in particular. Like, to me, I could rant about that forever, and I won't. But basically, where I start with that is that the A in API stands for application, and the API should be built around application use cases. we often start by like basically just crapping out our database as HTTP, and it's just a bunch of atoms. And like no web page is ever just like an atom. It's always some crazy composition. And so like because all of our frameworks steer us towards that implementation and make it really easy to crap out the atoms, we're basically changing the web architecture, because in the original web architecture, it was not like 1 million requests per page. It was basically one, and you get some images, and iframes came about, but it was essentially like request response, and you got the meat of it. Now, if you do it wrong, to your point, it's like 50 requests to build a page, and that's like I ran into that at Disney. I ran into teams building it that way. The other teams started building these like compositing layers to combat it. Those things started tipping over, and so I started imagining a system where you could basically composite your atoms like server side. And links were a big part of it. You could say the thing is a link, or it could be embedded. You could follow links server side to build compositions. Like clients could determine kind of the data set. I kind of thought it was like clients need a JSON DOM. They need a very particular one. We should be able to serve them that DOM. And that's not an easy thing with a lot of the frameworks we use. They're not built for that.
Right.
So, but yeah, I totally run into that all the time.
Yeah, it's awesome. There's a lot to talk about there.
Yeah, for sure.
The most common one I remember seeing is like you need to delete something, so you delete a route, but then you need to batch delete a bunch of things, and so
Yeah.
it ends up being a post request.
Yep.
Yeah. Do you have any sort of recommendation?
I do it that way, to be
Okay.
honest. Like, so post to me basically means like invoke a function.
Okay.
That's what I've taken it to mean as a method. It's kind of like the catch-all, where it's like it doesn't have direct semantics, but I almost think of it as like, I probably have a bunch of things wired into my brain that I associated with it, but I kind of think of it as like, old, in the old Windows days when you like post, like I kind of think of it as that, like you're actually sending a message and it's kind of an arbitrary one.
Gotcha.
It also tends to be associated with creation. And I think of that as like the analogy of like I'm posting a message on a message board. So I'm like adding content to a server like that didn't have it before. So post is often used for like, I'm gonna create new data and I'm gonna target some collection that's like containing a bunch of data. And I, as the client, don't know what the URI of this thing will be. Meaning specifically, the server is probably gonna have the ID of it, maybe it's in the database, and the server will tell me the URI after it creates it. If you are going to create something and you actually know ahead of time what the URI should be, most folks would argue, and I think I would argue, that put is actually the right method to use, because you're basically saying put this data at this URI. It's almost more like treating it like bucket storage or something. Like, here's the key, I know the key, you don't need to tell me the key, I know it, here's the data. So that's all just like art and like fancy, like it's not written down exactly, like none of that's necessarily even implied. A lot of this is inferred. So.
On the delete side of things,
Yeah.
with batch deletes, this was something that Rails was trying to solve with Rails 5. And they went through like a ton of different iterations on how you can handle batch deletes in the URI and have a bunch of crazy ID shit in the URI.
Yeah.
And then finally, like at the end of it all, they just went, this is ridiculous, we'll just use post. And they just like dropped the whole thing.
Yeah. Yeah, and there are some like HTTP methods that I don't have much experience with, like patch, and there's other folks that wanted to add more to it and stuff. So, I think until then we're going to be using the ones we have and maybe tunneling some stuff to some extent.
Would you say that a REST API is limited only to HTTP, or could you have it sort of transport? Because like Meteor, I don't know if you've done Meteor, but they have this thing called like DDP, which is basically like they open a WebSocket and then they send JSON messages back and forth. Yeah. Kind of like either side can send it unprovoked or as a response. And like it basically has like a resource path in it, and like sort of almost like all the headers, but as a JSON, but over WebSockets. Would you call that REST?
I would have to look at it more carefully, but like I wouldn't not call it REST because it's not using HTTP. That was a lot of inversions, but in other words, like REST doesn't require HTTP. REST doesn't require URIs. REST doesn't require HTML or JSON or any of these things. That's kind of what I was hoping that people would get out of this, and certainly what I got out of the paper, which is you can't read this paper without being a little bit confused, because what I find myself often doing as I read it is I try to map it to the real world. Like, oh, he's basically talking about HTTP here, he's basically talking about URIs, but he always uses the term like resource identifier. He'll never say URI. Sometimes he'll say like a URI. But yeah, so I wouldn't exclude it for the reason of like new protocols, but you would have to look at the constraints. Like, do we think, if we look at the constraints that define REST, do we think that this architecture exhibits all of them? So I don't know.
I want to go back to like one thing you said about like the API design.
Yeah.
It sounds like what you're saying is that previously people designed where the ultimate resource was a noun.
Yeah.
And now the ultimate resource might be a verb for the application.
Yeah, I sort of think of it a little differently. I think of it as it's still, I guess, a noun, or still like I mean, just getting real, it's like a body of content, but it's the body of content that client needs. So it's like, I guess my distinction is like, I would want to see people design APIs around use cases and be willing to think of their like representations or even their resources being very like app specific. Like, this is the data blob that defines screen 3. Like, let me have a resource for screen 3. Like, it's not necessarily reusable, but it is going to be scalable. Like, there's these trade-offs. Netflix is a great like example to look to in my mind, because they have that, like, met the challenge of having apps on like 600 or something unique devices, like crazy number of TVs and stuff they're built into. So each of those, not every single one of those, but many of those APIs are different from one another, and the differences are in the use and the needs of the client. And they happen to have a framework where it's relatively easy for them to introduce new resources through Groovy code. So they kind of like script, script their. It's almost like we'd write in the old days, write templates for HTML. They're basically like writing templates for responses to APIs. It's not really that revolutionary, but they have it sort of that agility of, it's like, oh, I'll just add another template. Whereas a lot of our frameworks feel heavier. Like, I have to do a lot of work. I have to add a whole big object model, and like it has to be a thing that it's in my database or something. I don't know, but so they've just kind of decoupled it a little bit. Well, let me ask, I guess, general question, like, of the room. Like, have any of you designed any APIs that you actually did include Hypermedia in? Yeah? So how did that go?
It's really hard.
Okay, yeah. Did it make sense ever? Did your clients did it make sense to your clients? Did you write the clients? Did anyone care?
Yeah, I mean, we're most of the tooling that we write around this is internal. So like the guy who's the consumer of the service that I'm writing is sitting 5 feet away from me.
That's the best way to do it.
Yeah, it is. It makes things really easy, and even that was not easy.
Okay. Well, whose idea was it to do links?
Mainly driven from my end, where I knew that there was a workflow that needed to be accomplished.
Okay.
The server knew what that workflow was, for a given resource, and you just get to a point where it becomes really difficult to deal with that.
Yeah.
Just because, like you said, there's a dozen. You listed 4 different JSON protocols. And there's equally as many in XML. And, it's all sorts of different data formats and flavors and there's no standardization around it, so you're making the game up as you go.
Yeah. So there's no like tooling support. It's just like super nascent, if it's even nascent.
I would say the most common use of Hypermedia I see in APIs is just the blah underscore URL that litters the hell out of the JSON doc, which I don't know if it's necessarily bad. Maybe you just add an extra thing to that's like URL plus methods available or whatever.
Yeah.
But anytime I encounter an API that has that, it's significantly easier to traverse. Like the GitHub API does that pretty well. Yeah. And it's so much easier to traverse than having to consistently go look at their docs like, okay, cool, you just gave me an ID, now what do I do? Yeah. Yeah, where do I put this? It's like they think it's fun for us to like decode it all. Yeah, and I mean, in the case of like, one of the main advantages I see in links, and I guess in a perfect world, what an API client server interaction would look like is like, I know the URI of the root. Like, it's hard to like skip knowing the doc root. Like, we all know that when we go to a website. But we never like when I go to ESPN or whatever, I don't type in any URL after ESPN. I'm just like clicking stuff. And that's kind of what I want the client experience to be. So like, and the nice thing is like, I don't actually have to care what the URIs are anymore. Like, they could be GUIDs, and that would be fine. But more importantly, they can change every day, and it still doesn't matter because I'm never looking at them and I'm never building them. So one of the arguments that I read recently was that there should be no versioning in APIs. The only reason it's there is because we're not using links. And one of the examples that, or just the statements that just kind of hit me was like, when's the last time you went to a versioned website? Like, or what, it's like it's not a thing. So
and it's links that really are making that possible. But anyway, I just thought that was interesting.
The only thing I'd add to the conversation is if you want to try it, the easiest place is if you're starting with like data that's structured like a tree.
Yeah,
that's a really great way to get going.
Yeah,
because then like
traverse.
Yeah, you know how to traverse it. When that tree starts to break down, or you're dealing with data that's actually a graph under the hood.
Yeah.
Now you're involving semantics and data replication and replacement and
cycles.
Yeah, it gets crazy so fast.
The part that bugged me with it is sort of like a separation of concerns thing, where usually the code I have that's like creating the models that I'm going to end up serializing to the web front door, like I don't want it to have URLs. Like that's like an artifact of like the last minute like API design. So just like the intermixing where the URLs actually end up in the data, for me was kind of the toughest nut to crack. Just like where do they come from? How do I generate them? So what I strove to do with frameworks that I've built on the side is that like basically the relationships would be modeled, and then the engine that's like the REST API engine would fill in the links based on the relationship. So that's kind of hand wavy, but basically abstract it so that there was enough metadata that the links could be created. So
you said that websites aren't versioned, but in apps they are versioned. Yeah. And there's a lot of REST activity going on with mobile apps. So you want to say something?
Well, I guess my thinking is that the versions are there to be sort of resilient to change, and specifically to change in the URI structure. Still work, So I guess the argument is that change in the URI structure shouldn't matter if you're using links, because what you're doing when you're using links is like even what Trotter said, the case where you have like a URI just like right in the middle of some JSON. Ideally, the key in that JSON is like something super stable. So that's what I think of like the link relations. Like you can think of the style sheet. Like that's a super stable like relationship label that the browser relies on every day. It's hard coded in every browser implementation that I should look for a link with that relation, and I should use it. I should assume it's a style sheet, and I should render and all that. But like it's become part of like the domain language of the browser. It's like a key word, and I think that's what we should hard code. We shouldn't hard code the ways that the slashes are and where they are, and like is it V1 or V2. We should hard code that I'm looking for the action called friends, and that's always going to make sense in this app, and the URI, like I said, could change all the time. So I think I mean I'm sort of oversimplifying it, I definitely get that for sure, but I think that's kind of where the versioning maybe comes from, at least in large part. Another subject that's interesting to me is the idea of like schemas, which is another place that versioning could actually come in, which is like, is anyone doing anything with actually supplying schemas either in their documentation or actually to their clients that basically describe the structure of any data that's being sent or received? Like JSON schema or DTDs if you're doing like XML. Yeah, you've done stuff with schemas?
Well, things I do in Clojure, you have a map and you expect certain keys. So you have to have those keys.
Cool. So it's like validation essentially. Cool. I like schemas. I tend to program in typed languages. So one thing I've always liked is the idea that a schema could help me marshal things into classes, things like that. So a lot of JavaScript folks like that, where that's kind of that's where their head's at. They don't necessarily see the need for the types as much, and I totally get that too. But I find them really useful. I kind of wish that schemas were just like a common thing, because I think it'd be really cool. I don't know if you guys use Swagger or any kind of API documentation tools, but one of the things think would be cool is if there was a schema along with your JSON response, then you could actually get like a HTML form generated based on your schema. So I could actually be like working with your data in a much more like type aware way, where I could know like the valid values for this field, or that this is an int, so it should give me like an int controller, this is a date. That kind of stuff. You can't get that without like some schema metadata that describes like more about the structure of the data. And it's just like, again, that's the kind of stuff that would level up the tooling with more self-description.
What do you think of, I guess, what they're calling modern frameworks like React, where it does a lot of client-side navigation, and so when you click a link, it doesn't necessarily make an API call. It runs local code that then maybe hits some API, pulls back JSON, and then knows how to marshal its own hypermedia back into the page.
I think that's totally cool, personally. I think it's definitely still using REST. It's not, all of those, it's not like old school web, but it's still using REST, right? It's still using all the same mechanics to communicate client server. Fundamentally, what's happening is just like the clients are getting beefier, right? Their processors are getting better. When I worked at ESPN, we had a purely server-side ad delivery model, and when we switched to client-side ad delivery, we went from like 1,000 servers to like 10. And it was nuts. Like we were serving over 1 billion ads a day. It was crazy. But that's the point, is like if you can make these devices which have decent processors do some of the heavy lifting for you, you definitely should. You don't pay for those CPU cycles. So I think that's just taking advantage, just being smart in the way the apps are designed. Yeah, I think I totally dig that style, and like I talked about my early career of doing applets. Like that's basically what we were doing. Like we weren't using it was before JSON. It was, I think, somewhat before JavaScript, but we would do like pipe delimited data fields. Like so when I'd write an applet that was like simulating a NASCAR race where cars were, like it was basically I'd hit a URL and I'd get back a data file that was pipe delimited. And in between like the third and fourth pipe, there'd be a URL. There'd be like the page of the driver, like his car image or something, right? So like it was like positional offset, like encoding or whatever. But it was basically like client server REST development, I guess.
Okay.
Yeah. So I think it's cool.
Cool.
Any other thoughts? What else do I have up there? Oh, I guess I mentioned Swagger. Does anybody use any like API tools that they think are really cool? Like, or the other one is like frameworks. Like anybody like throw out like their vote for like a tool that maybe other people aren't using or they think is cool? No?
OData.
Which one?
OData.
OData? Okay.
OData.
OData. Oh, okay, yeah.
For
schemas?
conventions and schemas
Yeah.
and resource navigation.
That's cool. So you've actually have use of it?
Mhm.
Oh, okay, cool.
Yeah.
Cool.
I mean, the reality, it gets down to one of those cases where you have clients, you have server side, you can just pull down libraries that do that work.
Yeah.
Why try and reinvent the wheel?
Yeah, exactly. So like they've created a standard and they built tooling around it. Yeah, I think that's awesome. That's from, who is that from? It's like a consortium, isn't it?
Yeah, and
it's like
Microsoft's put a lot of weight behind
it.
it.
Yeah, I remember when that came out. I haven't looked at it in a long time.
Yeah, so some great work there. I mean, you can pass, full expressions across through the URL.
That's cool. And they have plugins and support for it in like their IDEs and stuff? Yeah, okay, that's cool. Yeah. Cool. What about other frameworks, like people generally using the kind of web, like if you're implementing an API, is it usually, do you find yourself more often than not like coding the endpoints either with an annotation or, okay, so like you're writing your routing functions as code?
Yeah. I usually end up using micro frameworks anyway.
Okay.
These days they usually, for me, scale a little better, and I find at the end of the day I end up having to rip out, and as things get bigger, maybe replace the database with something else or with 3 other things or whatever you have. So it's easier to not be attached to some huge underlying thing.
Yeah, makes sense. Cool. Yeah. So.
Yeah, I guess on the topic of like frameworks, so Michael and I, we started using Angular. So with our main project, so before we used Angular, it's more like just to have like some components that will help us out. But now we're like shifting it so our application is actually a single page application. And so when we originally developed our app with as like a Flash server that's like serving up the pages like individually, but we still made like a lot of like restful API calls. So the shift over to a single page application has been like reasonably easy.
That's cool. Cool. And what are you using for the API side of things?
I'm sorry?
What are you using for like the server side implementation?
So we still just have our Flash server. So instead of serving templates now, we just like render an index.html.
Gotcha.
And then we just build a single page application on top of it.
Gotcha.
And if that turns well, we might decouple those completely into 2 separate apps.
Gotcha. Yeah, that's cool. Yeah, the whole like cross origin thing sometimes like gets in the way when you're trying to like separate your JS app from your API. Cool.
Awesome.
Cool. Well, yeah, thank you guys.
I don't mean to like force discussion if people seem done.
Yeah, I mean, I stick around if people want to talk. Yeah, I appreciate everybody showing up, and thanks for like helping us welcome everybody to Riot and kicking this off here.
Yeah, thank you guys all for coming. Again, thank you, Mark, Trotter, everyone here who helped you. This is really cool.
Cool.
Thanks. Yeah, thank you.
Thank you.